This is number 58 from 5.5 and Stewart. And the topic here is substitution, and this has a definite integral. So you can do substitution here because of the pi t inside of here. Notice if there wasn't a pi there, if it was just cosecant of t, cotangent of t, that would just be one of our basic antiderivatives, right? Like cosecant cotangent is, the negative of the derivative of cosecant, right? Like the derivative of cosecant of t would be negative cosecant of t cotangent of t. So the pi is just a constant multiple in there. So you can take care of it with a u substitution. I will say, when you get pretty good at this, and once you've done a bunch of these, when it's just a constant multiple like that, you might be able to skip the substitution and just kind of think, okay, chain rule backward with a constant multiple. But let's show it with the substitution. So the issue here is the pi t, right? Like let's let u equal pi t. And again, like with most substitutions, that's it's the function inside of the function, right? Pi times t is inside of these trig functions. And then your du is just pi dt. And so I need a pi, right? I have dt here. In order to get to du, I have to have pi dt. And you have to. If you're going to change to u for your function, then you absolutely need to change your dt to a du so that you can integrate with respect to u. So two ways to do it. One is to just put a pi in there, and then since you're multiplying by pi, also multiply by 1 over pi on the outside. That's how I normally like to do it. The other way, I'll show that this time, is to solve for dt. So to do that, you just divide both sides of this equation by pi. I like to write it this way, 1 over pi du. And so you can do it this way too, right? And you can replace the dt with a 1 over pi times du. And what I'm going to do is put the 1 over pi out front because constant multiples can be factored out of an integral. And I'm just realizing I'm not really leaving myself enough room here. So for how big I'm going to write with my pen size the way it is. All right. And anyway, so there's the 1 over pi du that's replacing the dt. And again, that 1 over pi, since it's a constant, it's just a number, I can actually bring it out of the integral. You cannot do that with a variable. Don't ever try to bring t or u from the inside of the integral to the outside. So we took care of the dt, turned it into a du. And now we can also turn all the pi t's into u's. And what you get is cosecant of u cotangent of u. Okay. And so far so good. Although I do want to say my work is a little bit, I'm being a little wimpy so far. I've just got an arrow here and it's not really the best use of the arrow. I'd like to preserve equality. So I was going to put an arrow and then say kind of equals. But as written, I just have to say these two things are not equal, right? This is a definite integral and this is an indefinite integral. And if you think, well, here's the question that I was going to ask. What is a definite integral? When you evaluate it, what kind of a thing, what kind of a mathematical object does it give you? Especially again, if those limits are constants like they are here, 1/6 and 1/2. Versus an indefinite integral, what kind of a thing does that give you? What kind of an algebraic or mathematical object does that give you? The answer to that is a definite integral, when you have constants for the limits, is going to give you a constant. It's going to give you a number value, right? Just a value. But an indefinite integral will give you a function of a variable, which is different, okay? And so those two things cannot be equal as written. So I need to do one of two things here. If I want this to be equals, I need to give limits of integration. And I either want to give the limits that we had here on t, or I need to change them to be limits on u. And so if I want to make them be limits on t, that's what these were, right? 1/6 and 1/2. I can use those, but I can't just write 1/6 and 1/2, because if I do just like that, the implication now, since this is all with respect to u, the implication is that these are u values, but they're not. These were t values. So this is wrong right now. So if I want to keep the values for t, I should write t equals in front of them. So now this is the integral of this stuff with respect to u from a t value of 1/6 to a t value of 1/2. This is one way to do it. And if you do it this way, usually the idea would be you integrate, then substitute the t's back in, and then use these values, right? So that's one way to do it. Alternatively, you can actually change these values to u values. And the way you do that is you just say, okay, 1/6 is a value for t. If I plug that in, I get 1/6 pi for u, right? I'm just plugging that 1/6 in for the t and seeing what it gives me for u. So if I do that, that goes from pi over 6 to, and then same thing, half. That's going to be pi over 2 up here. Now these are limits on u, not on t, and so I don't need to write u equals or anything because this says du, so this is all with respect to u, and this is correct now. This whole expression is equal to this whole expression. They're the same thing. Okay. Either way that you do it, the next step is to anti-differentiate, right? Let's take the antiderivative here. Cosecant of u, cotangent of u is the negative of the derivative of cosecant of u, right? So this would be negative cosecant of u. I have this 1 over pi in front. And I would put plus c if it was an indefinite integral. Since it's definite, I'm just going to put these limits of integration here. I'm evaluating from pi over 6 up to pi over 2. And you don't need the plus c because it'll cancel out. And yeah, now we just plug in those limits of integration and subtract. So I have negative 1 over pi times the cosecant of pi over 2 minus, and I'm just going to put like parentheses here. I have the negative 1 over pi factored out. The cosecant of pi over 6. However you do this, just be careful with the negatives. Factoring out the negative 1 over pi is maybe a little easier here because then I can do a grouping symbol and then just do cosecant of that minus cosecant of that. If you're going to distribute it, make sure you distribute the negative with it. All right, we're going to keep moving here. And so I am running out of space though. Cosecant of pi over 2, I'm just thinking it's 1 over the sine, right? So if I picture on the unit circle, pi over 2 is up here. The sine of pi over 2 is 1. So the cosecant of pi over 2 is 1 over 1. So this is negative 1 over pi, negative 1 over pi times, this is 1 over 1, so 1 minus. And then pi over 6 is down here, and the sine of pi over 6 is 1/2. So 1 over the sine of pi over 6 is going to be 2. So it's going to be minus 2. And so this is negative 1 over pi times 1 minus 2, which is going to be negative 1. So it'll be positive 1 over pi is the answer to this question. That's it.